Hello, I'm Seema and welcome to part 33 of the chapter Equilibrium. Moving ahead with our solution of problems for the topic ionization constant of weak acids, let me now do the solved example, that is question 7.19 of your textbook. The question is that the pH of a 0.1 molar monobasic acid. A monobasic acid is one that releases only one H positive ion per molecule when it ionizes in water. So the pH of a 0.1 molar monobasic acid is 4.50. Now what is given to us? The pH is given to us and the concentration of the initial concentration of the acid is given to us. You have to calculate the concentration of the species H positive, A negative and HA at equilibrium and also determine the value of Ka and pKa of the monobasic acid. Now what have we been given? We've been given C. C is 0.1 molar. We've been given the pH, which is equal to 4.50, right? And now you're supposed to find out Ka, you're supposed to find out pKa, and you're supposed to find out the concentrations of all the species at equilibrium. So let us write down the equation for this reaction. The equation, the acid, monobasic acid is HA. It combines with water to give you H3O positive plus A negative. Now you're supposed to find out the concentrations of HA. Initial concentration given to you is 0.1 molar, isn't it? Yeah. Initial concentration is this, and H3O positive initially and A negative initially are 0. The equilibrium concentrations you're supposed to find out. You're supposed to find out Ka, pKa, and the pH is given to you. Now using the pH, usually in the previous question we had calculated the pH. Here we've been given the pH. From the pH we can calculate the concentration of the hydrogen ion, because that is what it is. What is pH? pH is the minus log of the hydrogen ion concentration, right? So we know pH is equal to the minus log of hydrogen ion concentration. And we also know that it is, if the concentration of hydrogen is given in the power of 10, for example, if it is to the 10 to the power 7 is the concentration, minus 7 is the concentration of hydrogen, then pH would be minus log of 10 to the power minus 7, which would be the log of 10 to the power minus 7 would be minus 7, and minus of that log would be plus 7. Therefore, the pH of that solution would be 7. So in this case, what is the pH given to us? The pH given to us is 4.5. So how can you can use this to calculate the hydrogen ion concentration, would be equal to 10 to the power of minus pH, whatever is the value of the pH, the negative of that, the minus pH, 10 to the power of minus pH will give you the concentration of hydrogen. I hope I'm clear. Now the pH given to us is how much? 4.5. So this would be equal to 10 to the power minus 10 to the power 4.5. Because minus log of minus log would be pH, isn't it? So that would be 10 to the power of 4.5 is the hydrogen ion concentration. So if the hydrogen ion concentration is 10 to the power 4.5, you can simplify this and calculate this numerically. This comes out to be H positive. Therefore, hydrogen ion concentration, when you solve this, comes out to be 3.16. Sorry, pH is 4.5, so this would be minus 4.5, right? Minus of pH. So this would be minus 4.5. Therefore, this value comes out to be equal to 3.16 into 10 to the power 3.16 into 10 to the power minus 5. Right? So you've calculated the hydronium ion concentration, or the concentration of hydrogen ion at equilibrium. And at equilibrium, we know that this hydrogen ion concentration, which is 3.16 into 10 to the power minus 5, and the A negative is also the same. If this is 1, this is 1. So if this is this much, this is this much. So this would also be 3.16 into 10 to the power minus 5. And And what would the equilibrium concentration of HA be? It means that if it was a monobasic acid, if 1 mole of this broke, you got 1 mole of hydronium ion. So if 0.1 mole was the initial concentration and this much of it dissociated, then final concentration of HA would be 0.1 minus 3.16 into 10 to the power minus 5. Do you get this? These are the equilibrium concentrations. Now, what is the question? You have to calculate the equilibrium concentrations of H positive, A negative and HA. From this you can calculate the equilibrium concentration of HA. H3O positive and A negative are these, and when you calculate the concentration, this is also equal to the concentration of A negative, and the concentration of HA at equilibrium would be equal to 0.1 minus 3.16 into 10 to the power minus 5. Which would, and this number is so much smaller than the 0.1 that we assume in the textbook, that's how we assume it to be equal to 0.1. Right? If you assume this to be equal to 0.1, the equilibrium concentration, how do you calculate Ka? Ka, or equilibrium constant, would be equal to the concentration of H3O positive into concentration of A negative divided by the concentration of HA. And we ignore the water because it's a liquid and we do not take liquids. So this would be equal to, the concentrations of both of these is 3.16 into 10 to the power minus 5 whole square, because both are the same, so this into this would be whole square, divided by 0.1, because this is approximately equal to 0.1. So when you calculate this, this comes out to be equal to 1 into 10 to the power minus 8. 1.0 into 10 to the power minus 8 is the concentration, is the value of Ka. So what's the question? It says after finding out Ka, you're also supposed to find out the pKa. And what is pKa? pKa is nothing but minus log of Ka, or it is minus log of 1 into 10 to the power minus 8. So which would be equal to 8, right? Minus log of 10 to the power minus 8 would be 8. Therefore, pKa value would be equal to 8, right? So this was question 7.19. Let us now solve one more numerical problem in this video. And then we'll move on to the next topic, that would be the ionization constant of weak bases, but that would be the next video. Give me a moment, let me write down the next problem. So now, this is question 7.20 of your NCERT textbook. It is the solved example. Let me explain this to you now. The question reads that calculate the pH of 0.08 molar solution of hypochlorous acid, that is HOCl. The ionization constant of the acid is 2.5 into 10 to the power minus 5. You have to determine the percentage dissociation of the acid. You know, the reason that I've basically, it is the same, the entire process is going to be the same as we did in the previous two problems. But this part where it asks you to determine the percentage dissociation is the reason that I am solving this example too. So this is just, but this part is going to be something new that you would be doing. The rest is what we've been doing in the previous problems too. So let us start with the question. What have we been given? We've been given the concentration of the solution, that is small c, is given to us, which is 0.08 molar. It is hypochlorous acid. We know the ionization constant, which means Ka, is given to us, is 2.5 into 10 to the power minus 5. You have to determine the pH, right? And you're also supposed to find out the percentage dissociation. Now let us start with the equation first. Hypochlorous acid is HOCl aqueous. It combines with water, which is a liquid. Now the reason I'm writing these is again because when we write the equilibrium constant or the dissociation constant equation, the water is to be avoided. That's the reason why you usually write the states, the physical states, although I have not written it in the previous two problems when I solved them. But if you write these, you can justify although it is the examiner can assume why you did it, but it is always better to write down the physical states. So HOCl plus water will give you, remove the H positive, you'll get H3O positive, the hydronium ion which is aqueous, plus what are you left with? OCl or ClO negative, we say, call it. This is also aqueous, right? The initial concentrations were given to us, and what is the initial concentration? 0.8. HOCl was 0.8 molar was initial concentration. And initially the concentrations of H3O positive and ClO negative would be 0, right? And the ionization constant is given to us. Now you remember what was the next step that we did? We wrote the balanced chemical equation. We know that the Ka value is given to us, and if we wrote two equations, that is water with water, the equilibrium constant for that, or the ionic product of water, would have been 1 into 10 to the power minus 14, which is much smaller. Therefore this is the primary reaction, so we chose this to be the primary reaction. We wrote down the primary reaction, the balanced chemical equation, and we wrote down the initial concentrations. Now we assumed a degree of dissociation, and based on that degree of dissociation we assumed it to be alpha, and we wrote down the concentrations that would be expected at equilibrium. So we said that if the degree of dissociation is alpha, then C alpha would be the amount dissociated. Then the amount of H3O positive and ClO negative formed would be C alpha and C alpha, because it's a monobasic acid again. And the concentration, equilibrium concentration here would be this minus C alpha, and whatever that C alpha is. In this question, we are not bothered about the degree of dissociation. So we can assume that if this was 0.8 moles, then how many moles of this dissociated? So instead of writing C alpha, we can simplify it to be X, just an X, a value X. X and C alpha actually mean the same thing, only we are not going into the details of what was the degree of dissociation. That is why in this problem, when you look at it, you may get confused why has he taken X in the textbook. So X is simply because in this problem, we don't really care what the degree of dissociation is, because that has not been given to us. Had it have been given to us, then it would have been of concern to us that we must write the degree of dissociation, and that would change the calculations. So here let us assume that X moles got dissociated. If X moles got dissociated, this would be minus X, and X moles of H3O positive would be formed, and X moles of ClO negative would be formed. So what would be the equilibrium concentration? Equilibrium concentration of HOCl would be 0.8 minus X, H3O positive would be X, and ClO negative would be X, right? So now what is the question? The ionization constant of the acid is given to us. You have to find out the pH of the solution. What is pH? pH is the hydronium ion concentration. In order to find the pH, we must know the value of X. And in order to calculate the value of X, what do? We substitute these values in terms of the degree of dissociation, as we had said, in terms of X in the equilibrium constant equation. So what is equilibrium constant here? Equilibrium constant is H3O positive concentration into ClO negative concentration divided by HOCl concentration. And we ignore water because that's a liquid. So this would be equal to X square upon, what would this be? 0.8 minus X. Now hypochlorous acid is a very, very weak acid. It's an extremely weak acid. So this X would be very small in comparison to the 0.8. And since it would be very small in comparison to the 0.8, the equilibrium concentration, you can say, is approximately equal to 0.8 because it has hardly dissociated. So assuming that the Ka value is given to us, which is 2.5 into 10 to the power minus 5 is equal to X square upon 0.8. Why? Because I assumed the X in this comparison is so small that it is insignificant, and being in the denominator, it's approximately equal to 0.8, so I take this to be this. So from this I can calculate X square. X square would be 2.5 into 10 to the power minus 5 into 0.8, right? And from this, if I have to find out x, x would be the square root of all of this. So x would be equal to the square root of this entire value that I have calculated. And when I calculate all of it, I come to the answer, that is the value of x turns out to be x square here turns out to be 2.0 into 10 to the power minus 6. And if you find out the square root of this value, to find out x would be square root of 2.0 into 10 to the power minus 6. And when you calculate x, it will come out to be equal to 1.41 into 10 to the power 1.41 into 10 to the power minus 3. Right? So you found out the value of 1.41 of the value of x. And what is x? X is the value of the hydronium ion concentration. And what is pH? From this you can find out the pH. pH is minus log of hydrogen ion concentration or hydronium ion concentration, which is equal to minus log of 1.41 into 10 to the power minus 3. When you solve this, you come to the minus log of this you get is 2.85. 2.85 would be the pH of the solution. Now, what is the last part of the question? You have to determine the percentage dissociation of the acid. If you appeared for a test and let us say you got 7 marks out of 10, what is your percentage for this test? If you got 7 out of 10 in a test, 7 out of 10 into 100 would be your percentage, isn't it? If you got 7 out of 10, how much would you have got out of 100 means percentage. So from this, what do you understand? What is the percentage? Determine the percentage dissociation, which means what percent of the concentration dissociated. The amount dissociated, we know. We know the equilibrium. Okay, the equilibrium concentration was 0.8 because we said the x is not important. So 0.8 minus x here, the initial concentration was 0.8, and what was the amount that dissociated? That dissociated was x. So the percentage dissociation would be the amount dissociated upon the initial amount into 100. And what was the amount dissociated? Was x, and x that we have calculated is 1.41 into 10 to the power minus 3 is the amount that dissociated, divided by the initial amount was 0.8 into 100. And when you solve this, this comes out to be 1.76%. That was the percentage of dissociation. Right? Easy? I think after having solved these many problems and after having explained all the steps to you, it should be an easy job for you to understand the next topic that we would be doing in the next video. That would be the ionization constant of weak bases. The acids and bases basically are just different in their behavior. The rest, the way, the methods are the same. So with this, I'll finish this video. If you found it helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.